According to the National Electrical Code, low-voltage cables installed above drop ceilings must be secured or supported in a manner that prevents damage or excessive movement. NFPA 70, also known as the NEC, Article 725.56 states conductors shall be securely supported in place. NFPA 70, NEC, Article 725.57 states where conductors are likely to be exposed to physical damage, they shall be protected. To comply with the NEC, secure low-voltage cable above drop ceilings using a number of methods. Firstly, strapping or clips, which involves using cables strapped or clips at regular intervals, for example every 3 feet, to hold the cable in place and prevent sagging. Secondly, laying on top of grid. If the drop ceiling grid is strong enough, the cable can be laid directly on top of the grid, but it is vital to ensure that it is not kinked or pinched. Thirdly, hooking on ceiling joists. If the drop ceiling is suspended from ceiling joists, the cable can be hooked over the joists using cable ties or hooks. In addition to the NEC requirements, it is recommended to follow these best practices for installing low-voltage cable above drop ceilings. Use plenum-rated cable that is designed for use in air handling spaces. Keep cables away from heat sources and sharp edges. Avoid crossovers between power cables and low-voltage cables. Label cables clearly to identify their purpose. Inspect the installation periodically for damage or loose connections. Low-voltage cables installed above drop ceilings must be secured or strapped to prevent damage and excessive movement. Strapping, clips, or laying the cable on top of the grid are acceptable methods. Always consult the NEC and follow recommended practices for a safe and compliant installation. The NEC, National Electrical Code, is a set of standards and guidelines for safe electrical installations. It is published by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The primary purpose of the NEC is to protect people and property from electrical hazards. It provides detailed requirements for various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is often mandated by local and state regulations, ensuring that electrical installations meet minimum safety standards. Article 725 of the NEC specifically addresses Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. These circuits are commonly used for low-voltage applications such as control systems, security systems, and communication systems. Article 725 outlines the requirements for wiring methods, overcurrent protection, and grounding for these types of circuits. It distinguishes between different classes of circuits based on their voltage and power limitations, with each class having specific requirements to ensure safety. Section 725.56, mentioned earlier, emphasizes the importance of securely supporting conductors. This requirement aims to prevent strain on connections and to protect conductors from physical damage. By securely supporting conductors, the risk of accidental shorts, grounds, or open circuits is reduced, thereby enhancing the overall safety and reliability of the electrical system. Section 725.57 further emphasizes the need to protect conductors from physical damage. This requirement recognizes that conductors installed in certain locations, such as above drop ceilings, may be vulnerable to damage from mechanical stresses, environmental factors, or human activity. To mitigate this risk, the NEC requires that conductors be protected by suitable means such as conduit, raceways, or other protective coverings. Plenum-rated cables are specifically designed for use in air handling spaces such as above drop ceilings used as return air plenums. These cables are constructed with materials that have low smoke and flame characteristics, reducing the risk of fire spread and toxic fume generation in the event of a fire. The use of plenum-rated cables is often mandated by the NEC and other building codes to ensure the safety of occupants in buildings. Strapping and clipping are common methods for securing low-voltage cables above drop ceilings. These methods involve using cable straps or clips to attach the cable to the building structure, such as ceiling joists or the drop ceiling grid. The straps or clips should be installed at regular intervals, typically every 3 feet, to provide adequate support and prevent sagging. It is important to select straps or clips that are suitable for the type and size of cable being installed, and to ensure that they are properly fastened to the building structure. Laying cables directly on top of the drop ceiling grid is another acceptable method, provided that the grid is strong enough to support the weight of the cables without sagging or damage. When using this method, it is important to ensure that the cables are not kinked or pinched, as this can damage the insulation and increase the risk of electrical problems. Additionally, the cable should be arranged in a neat and orderly manner to facilitate future maintenance and troubleshooting. Hooking cables over ceiling joists using cable ties or hooks is a convenient method for securing cables in areas where there are accessible ceiling joists. Cable ties or hooks can be used to attach the cable to the joist, providing support and preventing sagging. It is important to use cable ties or hooks that are strong enough to support the weight of the cable, and to ensure that they are properly fastened to the joists. When installing low-voltage cables above drop ceilings, it is important to keep them away from heat sources and sharp edges. Heat sources, such as lighting fixtures or heating ducts, can damage the cable insulation and increase the risk of fire. Sharp edges, such as metal framing or conduit, can also damage the cable insulation and create a potential shock hazard. To prevent these problems, cables should be routed away from heat sources and sharp edges and protected with suitable coverings or barriers if necessary. Avoiding crossovers between power cables and low-voltage cables is another important consideration when installing low-voltage cables. Power cables carry high-voltage electricity, which can induce electrical noise or interference in low-voltage cables. This interference can disrupt the operation of low-voltage equipment and create communication problems. To minimize this risk, power cables and low-voltage cables should be kept separated as much as possible, and shielded cables should be used for low-voltage applications in areas where interference is a concern. Labeling cables clearly to identify their purpose is a simple but effective way to improve the safety and maintainability of electrical installations. Cables should be labeled with their circuit number, voltage, and function using permanent markers or cable tags. This allows technicians to quickly identify and troubleshoot cables without having to trace them back to their source. Additionally, labeling cables can help prevent accidental disconnections or misconnections during maintenance or repairs. Inspecting the installation periodically for damage or loose connections is an essential part of any electrical safety program. Electrical installations should be inspected at regular intervals, typically annually or biannually, to identify any signs of damage, wear, or deterioration. Common problems to look for include cracked or damaged insulation, loose connections, corroded terminals, and overheated components. Any problems that are identified should be repaired promptly to prevent them from escalating into more serious hazards. The National Electrical Code, or NEC, serves as the cornerstone for electrical safety in the United States. It's a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It's not just a suggestion. In many jurisdictions, compliance with the NEC is legally mandated. This ensures a consistent level of safety across various installations. The NEC is updated every 3 years. This process keeps the code aligned with technological advancements and emerging safety concerns. The updates reflect the collective knowledge and experience of electrical professionals, engineers, and safety experts. These professionals come together to refine and improve the code. The NEC covers a wide spectrum of electrical topics. These topics include wiring methods, grounding, overcurrent protection, and equipment installation. It provides detailed guidelines for residential, commercial, and industrial settings. These guidelines are specific to the unique challenges of each environment. The NEC aims to safeguard people and property. It minimizes electrical hazards such as shocks, fires, and explosions. By adhering to the NEC, electrical systems become more reliable. The risk of equipment failure and downtime is also reduced. Chapter 7 of the NEC addresses special conditions. These special conditions include hazardous locations, emergency systems, and low-voltage systems. Article 725, which is relevant to low-voltage installations, falls under this chapter. Article 725 focuses on remote control signaling in power-limited circuits. These circuits are commonly used for applications like security systems, fire alarms, and data communications. The article sets specific requirements for wiring methods, overcurrent protection, and grounding. These requirements are based on the voltage and power levels of the circuits. Class 1, Class 2, and Class 3 circuits are defined within Article 725. Each class has its own set of requirements. These requirements are designed to minimize the risk of electrical shock and fire. Class 1 circuits operate at higher voltage and power levels. They require more robust wiring methods and overcurrent protection. Class 2 and Class 3 circuits operate at lower voltage and power levels. They are considered safer, but still require careful installation practices. Section 725.56 is a key provision. It emphasizes the secure support of conductors. This prevents strain on connections. It also protects the conductors from physical damage. Approved methods include straps, staples, cable ties, and raceways. The spacing between supports is also specified. Section 725.57 addresses the protection of conductors from physical damage. This is particularly important in areas where cables are exposed to mechanical stress or abrasion. Protection methods include conduit, raceways, and protective sleeves. The choice of method depends on the specific environment. Plenum-rated cables are essential for installations in air handling spaces. These spaces are often found above drop ceilings. Plenum cables are designed to limit the spread of fire and smoke. They use special insulation materials with low flame and smoke characteristics. The NEC requires the use of plenum-rated cables in these areas. This requirement ensures the safety of building occupants. Strapping and clipping are common methods for securing low-voltage cables. These methods use straps or clips to attach cables to the building structure. Proper spacing and secure attachment are essential. This prevents sagging and damage. Laying cables on top of the drop ceiling grid can be acceptable. The grid must be strong enough to support the weight of the cables. Cables should be arranged neatly and without excessive bending. Avoid placing cables near heat sources. This prevents damage to the insulation. Hooking cables over ceiling joists is another option. Cable ties or hooks can be used to secure the cables. Ensure the ties or hooks are strong enough. Proper spacing is also important. Avoiding crossovers between power cables and low-voltage cables is crucial. Power cables can induce noise and interference in low-voltage cables. Maintain physical separation between the two types of cables. Shielded cables can also be used. Labeling cables is a best practice. Labels help identify the purpose and destination of each cable. This simplifies troubleshooting and maintenance. Permanent markers or cable tags can be used. Inspecting installations regularly is essential for maintaining safety. Look for damage, loose connections, and signs of overheating. Repair any problems promptly. This prevents further damage and potential hazards. In summary, installing low-voltage cables above drop ceilings requires careful attention to detail and adherence to the NEC. Following these guidelines ensures a safe and reliable installation.